Hi, I'm Jagadeesh Kumar Sellappan, and this is my AAI-540 final project, CX Cortalyst, an automated customer sentiment analysis and GenAI response system. Businesses on platforms like Yelp receive thousands of reviews, and manually triaging negative ones to write a thoughtful response takes hours of staff time every day. By the time a business replies, the customer has often already churned. CX Cortalyst solves this with two things: a binary sentiment classifier that flags negative reviews in batch, and GenAI component that drafts a personalized apology response for every one of them, ready for a human agent to review and send. I built this end to end on AWS SageMaker from raw data ingestion through a full CI/CD pipeline with automated quality gates, monitoring, and drift triggered retraining. Here is the full system architecture. Data starts as raw Elf JSON files, about 6.93 million reviews, which I load into S3 data lake, register the schema with Glue, and run pushdown SQL join in Athena to flatten everything into a single feature table. I store the structured feature table, including raw review text, in SageMaker feature store. Then at training time, I generate 384 dimensional text embeddings from that stored text using all mini L6v2 embedding model and combining them with structured features like review length and elite user status to build the full 390 column training metrics. For training, I benchmark with logistic regression, then train XGBoost, that's the model that goes to the model registry once it clears a quality gate. For deployment, batch transform classifies incoming reviews, and any review flag negative gets routed to JumpStart LLM that drafts response, which a human agent reviews before sending. And running underneath all of this is a monitoring layer with a CloudWatch and model monitor wired into CI/CD pipeline that can automatically retrain the model if performance drifts. Let's walk through each piece live in AWS. This is my feature store, Help Sentiment Features V1. It is configured as offline store only, which means I'm not paying for the online store's per record cost since this is a batch use case, not real time. This tab lists the registered feature definitions. The record identifier is review ID, and event time tracks when each record was ingested, which gives me point in time correctness if I ever need to reconstruct training data as it leaked on a specific date. And you can see the text feature. The raw review text is registered and physically stored in the offline S3 store. That's what feeds the embedding generation step at training time, where this raw text gets converted into 384 dimensional vectors and merged with the structured features to build the full 390 column training metrics the model actually trains on. Offline store writes to S3 in Parquet format, partitioned by ingestion time. That is what feeds my training and CI/CD pipeline splits. So this is the model registry. You can see 7 versions are here, all marked approved. That reflects iterative retraining as I refine the pipeline across the project. Version 7 is the latest, registered from my most recent successful CI/CD run. The overview tab shows train complete, evaluate complete, and deploy status approved, meaning this model is successfully cleared the quality gate before being registered. The built-in metrics here show the XGBoost, training, and validation log. For the full evaluation metrics, F1 accuracy and AUC ROC, those are captured in the evaluation report generated by the pipeline. Let me show those. Here are the pipeline evaluation results. Macro F1 0.8930, accuracy 0.8930, AEC ROC 0.9639, all computed against the held out test set by model evaluation step. That F1 of 8930 cleared my 0.85 quality gate threshold, which is exactly why this model reached approved status in the registry. Only models that pass the gate ever get registered as approved. If a retrain comes in below 0.85, the pipeline halts at the quality gate fail step and the previous approved version keeps serving production traffic. So next I would like to show the batch transform output by the approved model. So this is the output of my batch transform job. It ran the approved model against the 500 held out production records to simulate a real daily inference run. I'm loading the processed Parquet file directly in Notebook 4 since that gives a cleaner view than browsing raw files in S3 console. So each row has the predicted probability, the predicted label, a review ID for full prediction traceability back to the feature store, and true label for monitoring comparison. On this production batch, the model scored a macro F1 of 8477 and the accuracy of 8504, about a 3-point drop from the test set F1.8779, which is expected and within healthy tolerance. The production holdout is a balanced 50-50 split versus the naturally imbalanced test sets, so a small delta is normal and confirms the model generalization well to unseen data. This negative labeled subset, every review where predicted label equals 0, is exactly what feeds into GenAI response step, which I'll show you in a few minutes. This is my CloudWatch dashboard, CX Cortalyst MLOps monitor. It's a single pane of glass with 6 widgets pulling from a custom namespace I called CX Cortalyst Sentiment MLOps. I'm viewing a 2-week custom window here showing activity from June 15th where I ran the pipeline. The top tracks test F1, production F1, benchmark F1 side by side. You can see the dotted line 0.85, that is my viable F1 threshold. Test F1 sits at 0.8779, above 0.85 minimum viable threshold. Production F1 at 0.8477, slightly below that line. The 0.85 threshold is the CI/CD quality gate for registering a new model. Once deployed, the production alarm only fires if F1 drops below 0.79, a 10% degradation from the 0.8779 test baseline. Top right tracks F1 drift delta, the gap between production and test performance. You can see the warning threshold at minus 0.05 and critical at minus 0.10. You can see the drift line dipping below the warning threshold here. That's the adversarial drift simulation I ran, which deliberately pushed the metrics down to validate the alarms. Under normal production condition without the simulation, the drift would sit above that minus 0.05 line. Bottom right shows both alarms, CX Cortalyst F1 drift warning and CX Cortalyst F1 score degradation, both currently green and healthy. In production, this pipeline would run on schedule. Both alarms are designed to eventually trigger automatic CI/CD retraining. That wiring is on my future enhancement list. The simulation injected 500 adversarial records, text character length 14 times baseline, review useful words 44 times and funny words 100 times. Every single feature flagged as drift detected. Both alarms are firing. F1 degradation at 0.72, below my 0.79 threshold, and F1 drift warning as negative 0.16, the below negative 0.05 threshold. Here is the drift simulation. The chart shows the F1 score timeline, days 1 through 4. The model holds steady above both thresholds. On day 5, the adversarial data kicks in. F1 drops to 0.72, crossing into the alarm zone. And this chart confirms it. Both F1 degradation and F1 drift warning bars are fully in alarm state after the drift injection. Before the drift, they were green and healthy. After drift, both flipped to red. This validates the entire monitoring layers is working exactly as designed. In a real deployment, this alarm state is what triggers the CI/CD pipeline to automatically retrain. Let me show you the pipeline now. This is my CI/CD pipeline built with SageMaker pipelines, 6 steps: data preprocessing, XGBoost training, model evaluation, and F1 quality gate, register model, and batch transform. I built 2 pipelines definitions to clearly demonstrate both outcomes. This one CX Cortalyst sentiment pipeline uses my real threshold 0.85. In this successful run, pre-processing generated the embeddings and structured features, training ran XGBoost, evaluation computed on F1 of 0.8930, and because that cleared my quality gate threshold, the pipeline proceeded to register the model and run batch transform automatically. Here is the failure state: a second pipeline definition with F1 threshold set to unreachable 0.099. You can see pre-processing, training, evaluation all succeeded, but the F1 quality gate step evaluated false, so it routed to quality gate failed instead of registered model. The pipeline halted right there. The previous approved model in the registry were left untouched and no degraded model ever reached production. This is a safety mechanism that makes the whole system self-healing instead of self-destructing. Next, batch transform prediction output flows directly into this final stage, the GenAI response module. This notebook takes the 10 most confident negative predictions, deploys flan T5 Excel through SageMaker JumpStart, generates a draft response for each one, and immediately terminates the endpoint. Here is a real example. The customer complained about salty food, small portion sizes, and rude cook. Genuinely negative review. The model drafts: "We are sorry to hear that you had a bad experience with us. We'll do our best to make things right." Short and professional and appropriate tone. And it is immediately tagged pending human agent review. The AI never sends anything directly to a customer. A real support agent reviews, edits, approves before anything goes out. 10 out of 10 drafts generated, average inference time 14.2 seconds, all saved to S3. The endpoint is then terminated immediately, no idle charges between runs. That completes a full end-to-end pipeline from raw Yelp reviews through feature engineering, model training, CI/CD quality gate, monitoring, and GenAI draft response. A few honest limitations and where I would take this next. 3 concrete enhancements. First, embedding generation inside the CI/CD pipeline. Right now, the training pipeline has full pre-processing with embedding generation, but the production inference path requires pre-computed feature CSVs. A future enhancement would add a production pre-processing step that takes raw incoming reviews, generates embeddings, and feeds them directly into batch transform. A fully automated raw text to prediction pipeline. Second, multi-class sentiment. The current system is binary, positive or negative, and 3-star reviews are excluded entirely. Expanding to 3 classes, positive, neutral, and negative, would capture the nuanced middle ground and allow differentiated GenAI responses, a follow-up question, or a neutral reviews rather than a straight apology. Third, automated GenAI response quality scoring. Right now, drafts go straight to human review with no automated quality check. A future enhancement would add a second LLM as a judge, scoring each draft on tone, factual accuracy, and brand voice, and routing low-scoring drafts to a higher priority review queue while high-scoring drafts move through faster. On the risk side, the biggest one is data retention and consent. A real deployment touching actual customer data needs a much closer look at those policies. And the GenAI responses absolutely require human review before anything reaches a real customer, which is exactly why I built the step in as mandatory, not optional. To wrap up, CX Cortalyst automates a full customer review pipeline on AWS. Data ingestion, feature engineering, XGBoost, sentiment classification, a self-healing CI/CD pipeline with a quality gate, live drift monitoring, and a human reviewed GenAI response layer. The model hits macro F1 of 0.8779 on the test set and 0.8477 on the production batch. The monitoring alarms were tested and proven. The quality gate has both success and failure paths demonstrated. All code is on GitHub, linked in the submission with full design documentation. Thanks for watching.